Welcome to Homework Lib.
Hi. So for this question, the first thing that we need to review is a couple of concepts regarding the cell potentials and when something is going to be spontaneous or not. So, for example, the delta G naught for a redox reaction occurring in a cell is going to be equal to minus n times Faraday's constant, the standard potential of the cell. So for a reaction to be spontaneous, we require that this zero needs to be larger than zero for having a spontaneous reaction. The other information that we get is that starting from this expression for delta G, we can arrive to the nearest equation that tells us that E is equal to the E standard plus minus RT divided by NF logarithm of Q. So in our scenario, what we're going to have is A+2 in aqueous media plus two electrons are going to produce a solid with an E0 potential equal to 0.85 volts positive. And we have another fictitious species that will be B plus 2 in aqueous media. Same thing, plus two electrons. This is going to produce B solid with an standard potential equal to 0.4 volts. So the corresponding cell that we should get would be in the cathode. Remember, in cathode, we have the reduction. So the cathode should be a, a solid because over there we're going to see the reduction reaction. And in the anode, remember, we're going to have the oxidation. Thus, the anode should be made of B solid. Why is that? Because with this setup, we're going to have a value for E0 of the cell being positive. Remember that E0 of the cell is equal to standard potential of reduction of the cathode minus E0 reduction of potential of the anode. For this calculation, our value for E0 is going to be equal to 0.45 volts. So now, we want to know the potential for the non-standard cell. So that is E is going to be equal to E0 minus RT divided by NF logarithm of Q. A reaction that we're actually going to have occurring over here would be A2 plus B solid producing B2 plus B solid. Sorry, plus A solid over here, right? As a solid. That means that Q will be equal to concentration of B2 plus divided by concentration of A2 plus. Remember that solids are considered to have activity 1, thus do not enter into the value for Q or for equilibrium constants. The values that are provided to us are the following: 0.1 of B2 plus and 1 molar of A2 plus, which is going to give us a value for Q equal to 0.1. Now, we are not given the temperature over here, so let's assume that the temperature is going to be equal to 298 Kelvin. If that is the case, we can use the reduced form in base 10 for the nearest equation. These forms are both going to be equivalent, but the only thing that changes is that we have a change from natural logarithm into log 10. So the new equation is E equal to E0 minus 0.059 divided by n, that is the number of electrons that are being exchanged. In our case, it's going to be 2 log 10 of q. So we already did the calculation for E0, and we know that n is equal to. So the potential of the cell would be 0.45 minus 0.059 divided by 2 log base 10 of 0.1. The result of E will be 0.4795 volts. And this would be our final answer. Thank you very much.